Hello all. Today we're going to talk about choosing your university physics course. There are a lot of different things to take into account, and these are just some of the things I think are important when choosing your university and the course you're going to study at that university. Needless to say, there are a broad range of personal and geographical factors that will affect where you want to spend the next 3 to 4 years of your life studying, so in this video I'm only going to be talking about academic concerns. Also, a disclaimer, I'm not going to be advocating any particular choices of university, rather giving some hopefully useful criteria you may find useful in weighing up your options. The first choice you'll make when applying for a physics degree is choosing whether to apply for a 3-year bachelor's degree or a 4-year integrated master's degree. Different universities sometimes have different names for the qualifications they offer. In general, the 3-year bachelor's degree is called a BSc, standing for Bachelor of Science, except for at Oxford and Cambridge where it's called a BA, meaning Bachelor of Arts. The master's degree is usually called an MSc, standing for Master of Science, or sometimes an MPhys, standing for Master of Physics. These titles really don't matter. The important part is the first letter, the B or the M, which indicates the level of the course. If you choose the bachelor's degree, you'll leave qualified to go into most graduate roles in fields like education, finance, software development and more. You'll also be eligible to apply to master's degrees in the UK and some PhD programs in the United States. To apply directly to PhD programs in the UK though, you generally need a master's degree. It's important to be aware that an integrated master's is considered an undergraduate degree solely for the purposes of student finance. If you complete a bachelor's degree and decide you want to pursue a master's degree afterwards, that master's degree will not be funded in the normal way by student finance. The integrated master's means you get 4 years of education provided by Student Finance England automatically, assuming you're a UK citizen, rather than having to fund the master's separately, which you would have to do if you completed your bachelor's degree and then chose to do a master's degree separately afterwards. There are some loans available for master's degrees, but they don't work quite the same as the undergraduate student finance loans. If you choose the integrated master's degree, you'll be qualified to go into the same kind of roles as somebody with the bachelor's degree, and possibly some more selective roles that require a master's qualification. These could be more competitive or better paid, something like that. You will also be eligible to go straight into a PhD in the UK, which you would not be otherwise with the bachelor's degree, if that's something you want to go into. In terms of content, the first 3 years of the integrated masters are pretty much the same as the 3 years of the bachelor's degree. There may be some differences in modules in later years, so you may have to take some additional modules in the 3rd year of an integrated master's compared to the bachelor's degree, and there may also be differences in project work, but on the whole they're pretty similar. A lot of universities will impose a minimum grade requirement for 2nd and 3rd year examinations in order for students to progress onto the 4th year of the integrated masters. If you didn't make this requirement, you'd still get to leave at the end of the 3 years with the degree you obtained, assuming you did well enough to obtain a degree, so that isn't too much of a concern either. For practical purposes, it's better to apply directly to the 4-year integrated masters than it is to apply to the 3-year bachelors. This is because it's easier in terms of student finance to apply for 4 years right at the beginning than apply for 3 years and then decide later on you need an additional year. Whereas if you applied for 4 from the beginning, it's clearly much easier to just say to student finance you don't actually require the funding for the 4th year than it is to ask for an extra year's funding. In fact, some universities have removed the option to apply to the 3-year course altogether. At Oxford, for example, all students are automatically admitted onto the 4-year MPhys course, and then at the end of the 2nd year they have to decide whether they want to go straight on to the bachelor's course and graduate at the end of their 3rd year, or if they want to stay on for the 4-year MPhys course, as there's a difference between what you have to do in 3rd year depending on which course you're on. A joint honours course is a course hosted by more than one department in the university. The most common partner for joint honours courses for physics degrees is the maths department, but there are lots of different combinations you can find at other universities. For example, some are in the chemistry department, or the materials science department, engineering departments, or even the music department or languages departments. In general, joint honours courses can involve more work than single honours courses. That is because not only do you need to satisfy the module requirements for the physics department, but you also have to satisfy a certain minimum number of module requirements for the other department that you're studying under. There are a number of benefits of studying joint honours courses. You may have a broader field of subjects in which you could specialise in later on in your degree, and there are also academic benefits of studying 2 closely related subjects in different departments. If you take a single honours physics course, it's likely that most of your maths lectures will be run by professors from the physics department, whereas if you're on a joint honours maths and physics course, a lot of your lectures will be taken by maths professors in the maths department. The style of teaching even the same content can vary a lot between the maths department and the physics department. Learning maths from mathematicians rather than physicists is bound to be a different kind of education. Not necessarily a better one, which depends entirely on your tastes and personal preferences, but it would certainly be easier for you to proceed into certain more mathematical areas of physics research after having received a more rigorous mathematical grounding in your education. At a number of universities, it is also possible to switch from a joint honours course at the end of your first year onto either one of the single honours courses that make up the joint honours course. However, it's often not so possible to switch from the single honours course in one department to then a joint honours course involving that department and another one. That's because generally each department will have some minimum prerequisites that you're required to take in their department in order to proceed on to the next year of study. When you look on the web pages of certain universities, you may see a large number of different courses all hosted at the same department and same university. These could be courses like astrophysics, theoretical physics, or physics with astronomy, things like that. Generally, it's very easy to switch between these courses at the end of your first year if they're all hosted by the one department, but these names can still be confusing. For the most part, courses like this run solely by the physics department will share many modules in common. If you're on the astrophysics course, your modules may be restricted in later years to more astrophysics options, and you may not have as many options outside of astrophysics, in areas like particle physics, say, as somebody on the straight BSc physics course. Somebody on the BSc physics course would still be able to take most, if not all, of the available astrophysics options. The point is, not taking the BSc or MSc astrophysics course does not prevent you from taking astrophysics modules at some point during your degree if you're on the BSc physics course. In my opinion, you shouldn't worry too much about specialising so early on. The first 3 years of a physics degree isn't meant to be especially specialised, and asking students to choose between an astrophysics degree or a particle physics degree before they've even got to university seems a little bit unrealistic. People don't usually decide what subfield they want to work in until their master's year, or even sometimes at the start of their PhD. What's important in the bachelor's degree or first 3 years of the integrated master's degree is getting a solid grounding in the core skills and basic knowledge of physics that is needed in any kind of subfield that you'd like to go into. You might want to look into what kind of research is done in the department you're applying to. This really shouldn't be your main concern though, as you're not expected to know what kinds of physics you most enjoy, and really you'd be unwise to be fixed too much onto one particular idea too early on. You're supposed to discover that during your degree. But if you're excited about particle physics, or interested in astronomy, maybe you could look into the universities which have strong links to CERN, or big telescope projects. As you'll definitely use some kind of project work during your degree, it can be really exciting to get to deal with data from these big collaborative projects, and make a real contribution to things like that. A lot of universities give their students the option to apply to work on a research project in the department over the summer. If you're interested in doing a PhD, doing one or more of these research projects across the duration of your degree is a really big advantage and something you should definitely look into. But even if your university doesn't have one of these programs, there are still a lot of different programs at other universities you can apply to. For example, during my degree, I spent 2 summers working at the California Institute of Technology on a couple of different research projects through their SURF program, which was a really great experience and I definitely recommend it to anybody. Some universities offer courses with the option of spending a year of your degree at a foreign university. If this is something that appeals to you, you may want to look into which foreign universities are paired with your prospective university, or which kind of institutions people typically go to on these exchanges, if you have some kind of preference for institution or location. Some universities also offer courses with a placement year. A placement year is a year spent working in industry or some facility, usually between the 2nd and the 3rd year of study on your degree. This kind of program is usually more geared to those interested in applied physics or engineering physics. At most universities, it's the case that you could switch onto the course with the placement year after having already begun your degree, but do bear in mind that not all universities give the option of a placement year, so if that is something you think you may be interested in, you should perhaps take a look into which kind of universities do offer courses with placement years, or the option of switching to a placement year once you begin. There are loads of different university league tables, and frankly most of them are not particularly useful to look at. It's unfortunate, but it is often the case that employers will favour people coming from higher ranking universities. The Russell Group is a group of such universities that employers typically like the look of, as silly as that may be. Fortunately, those in the know, such as professors looking for PhD students, know not to judge students purely by the name of their university. And even in the world of work, there are lots of things people can do to make themselves look much more attractive to employers, none of which I'm at all qualified to talk about, as I have never had so much as a paper round's worth of job experience. But somebody, I'm sure, will be able to give you tips on that. Universities also publish statistics on what their graduates do after they graduate. Often this will be in the form of the percentage of graduates in full-time employment or further study within 6 months of graduating. However, these are not typically filtered in terms of what sort of positions the graduates go on to achieve, so do be a little sceptical about this data. The Institute of Physics has a scheme for accrediting degrees offered by UK universities. If a degree is accredited by the IOP, it means it fulfills some minimum content taught and skills imparted. This can be a useful thing to look out for, as it is a good sort of baseline quality check on the courses you're applying to, but do bear in mind that if you're applying to a joint honours course, it may not be accredited by the IOP due to missing out some deemed necessary content in place for other departments' content, but then it may be recognised by the IOP, which is a slightly different requirement. The IOP also has a really good course finder you can use to filter physics courses based on location, accreditation status, joint honours and things like that. There's also an option to search for universities based on their Project Juno status, which is a project ran by the Institute of Physics based on promoting good practice and the advancement of gender equality in physics departments. So those are some of the factors you may want to consider when choosing your undergraduate physics degree. I've put a few links in the description that go into a bit more detail about the things I've talked about, including the IOP Course Finder website, which I would really recommend taking a look at. I hope you found this video useful. If you did, it'd be great if you could leave a like and share it with your friends. And also don't forget to take a look at my website, cosmicconundra.com, and also follow me on Twitter at cosmicconundra for updates on videos and problems. Okay, thanks a lot for watching. Speak to you all soon.